Great. Thank you, Abhijit, for confirming. All right, guys. So I hope you guys had an exciting quiz. We did just 10 questions, and I saw that some of you did really well in the quizzes. So congratulations to all of you. We'll get into the explanation of all the questions today. I'll try to give you better methods, also the mathematical methods of solving these questions one step at a time. But yeah, let's start with a quick intro about myself. Those of you who don't know me, I'm Piyush Beriwala. I'm going to be your host for the next 30, 40, 50 minutes, whatever it takes to kind of go through these 10 questions in a systematic fashion. I have prepared for GMAT myself as a student. I have prepared for CAT as well, which is an Indian version. In a way, you can say for Indian MBA programs, you can do CAT. And I've taught for both the tests. I have scored a 740 in GMAT Classic with Quant 50 verbal 49 and a 99.9 percentile on CAT. And personally, I love analyzing trends and data to come up with strategies. So that's just a quick intro about myself. Let's get into the first question. Now, the first question, and I'm assuming that all of you have solved this question, okay? So I'm not gonna give you time to solve this again. I'll just dive right into explaining this question. Now, there are multiple ways to solve this question. Now, if you see this question, it says x when divided by 10 leaves a remainder of 4. If x and y are both positive integers, where y is the quotient, what is the remainder when x is divided by 5? Now, there is a mathematical way of doing this question, and there is a logical way of doing this. Now, I would always try to teach you both the methods. In this case, you can follow either of them. However, logical method is better. So if you notice the language, it is very clearly saying that what is the remainder when x is divided by 5. Now, the word is a very certain word, right? It's a very confirmatory word. It's not saying what may be the remainder or what can be the remainder. When you know it says what is the remainder, and GMAT being a time test, you don't have to like write down all the mathematical steps in your notebook to answer the question, because there's no marks that you get for, let's say, writing all the steps down. You need to solve the question in the fastest possible way. Now, if you see what is the remainder, you can very well take any value for x that when divided by 10 leaves a remainder of 4. So if you think of one value of x that when divided by 10 leaves a remainder of 4, it is 14, right? 14 when divided by 10 leaves a remainder of 4. So you can very well take x as 14. You can also take it as 4, by the way. Some of you might be more smarter, can take it as 4 also, because that also leaves a remainder of 4. But if that doesn't strike you, 14 strikes you, that's also okay. So simply divide x by 5, which is 14 by 5, and you find the remainder. It will be 4, and that's your right answer. So you can always look at these fine things in the question stem, which allows you to use numbers to solve the question. So here it is saying what is the remainder. However, had the question been slightly different, had the question been talking about, let's say, what could be the remainder, what may be the remainder, or what is the sum of all possible remainders, you may not be able to plug in numbers. In that case, you need to use a mathematical approach, which is more around, let's say, using a remainder theorem. So there is a remainder theorem. You can use that, and you can write x is equal to 10y plus 4 if you want to, and then you can simply divide 10y plus 4 by 5. And those of you who know the remainder theorem, you know that the remainder is a combination of the remainders obtained in these two different parts. So this part is divisible by 5, so it leaves a remainder of 0, and this part leaves a remainder of 4. So my final remainder is 0 plus 4, which is 4. Now, those of you who don't know the remainder theorem, please feel free to go ahead, read more about it. In GMAT quiz, we cover it as a part of our curriculum as well. But as I said, in this case, I would recommend you to use the logical method. And the clue is the word is. That certainty in the word allows us to pick a number and answer the question. I hope all of you are fine with it. Okay, let's go ahead to the next one then. Okay, now this one, for example. Now, what is tested in this question? In reality, if you see, this is more like a trap question, because it kind of might set you into thinking that, okay, I have to think about how does the number end, or what are the number of zeros in the end. All of that you might get into thinking. But in reality, if you nail this question down, you will understand that a number ends in 0, basically in 1 0, if you can write the number in the form of x into 10. Correct? So if the number is in the form of x into 100, it will end in 2 zeros. If the number is in the form of x into 1000, it will end in 3 zeros always. So technically, what the question is asking you is, in reality, that how many tens are there in 60 factorial? Now, if you need to find the highest power of 10 in 60 factorial, you should write it in the form of 2 to the power n into 5 to the power n. So technically, you have to find the highest power of 2 and highest power of 5 in 60 factorial. And whenever you have to solve such a question, you should not find, you don't need to find the highest power of both the factors. You just need to find the highest power of the higher factor, because the idea is that 5 is gonna be more scarce than 2. You'll find a lot more 2's in 60 factorial than the 5's. So the highest power of 5 is what will drive eventually how many zeros will be at the end of 60 factorial. So all you need to do is calculate the number of 5's in 60 factorial. So how do you do that? Just do this division. Divide 60 by 5. Whatever is the quotient, write it on the side, and keep dividing the quotient by 5 and keep adding the quotients down till the time you reach the quotient of 0. Once you reach the quotient of 0, that means that's the maximum number of 5's that you can find. So in this case, the answer is 14, because there are maximum 14 5's that I have, and there will be a lot more 2's, but I will only be able to use 14 of them to get to 10 to the power 14. So there will be 14 zeros. So those of you who know this concept, great. If you don't know this concept, we have taught this under prime numbers module of GMAT Quiz in depth, and there are a lot more complex questions of this variety that I've seen coming on GMAT. Okay, but yes, this is again a easy medium level question is what I would rate this as. Okay, now the next question that we have in front of us is a work rate time question. Now, again, there are two ways to solve this question. One way is the mathematical way. Again, both the methods are actually mathematical, but I would say the second one is more logical in comparison to the first one. So the mathematical way or the usual way of solving this question is that you take A's rate as 1 by 5, B's rate as 1 by 10, and C's rate as 1 by 20. Now, many of you might know that method of solving, and I'll come back to that a little later, but I'll tell you a logical way of solving this question. So the logical way of solving this question in this case is you assume the work to be 20. What is 20? 20 is basically the LCM of the day's individual time that these people take to complete the job. Okay. Now you simply form a work rate time table for ABC. Okay. I'm just drawing it roughly on my screen right now, so don't pardon me for my handwriting, not the best, but I'll still try to make it as legible as possible. So I know total 20 unit of work is what they can do. This person A can do it in, let's say, 5 days, B can do it in 10 days, and this person can do it in 20 days. So I can find the rate of A by dividing work by time, which is 20 by 5, right? I can do 20 by 5. So A's rate per day will be 4, B's rate similarly per day will be 2, and C's rate will be 1. Now, please understand, I'm drawing this work rate time table just to make you explain this process. Okay, we can understand this process if you're seeing this for the very first time. Once you become a pro at using this process, you don't even need to make a table. Most likely, you can do it in your head, all in your head. Like just assume work as 20 and use work by time to calculate the rate. Now, once you have the rate, this is rate per day of work, correct? Because you are dividing it by number of days. So if you see, the question is asking, how many C's, machine C's, must assist 2 machine A's? So I know for sure there are 2 machine A's. Now, what is the rate of machine A? It is 4. So in one day, 2 machine A's will do 2 into 4 units of work, plus 4 machine B's. Now, 1 machine B does 2 units of work, so 4 machines will do 4 into 2 units of work. So that is 16 units of work already done. Now, I need to complete 20 units of work in one day, so there are 4 units of work remaining. Now, 4 units of work need to be done by machine C, which has an efficiency of or rate of working as 1 unit. So I can do 1 unit with 1 machine. So I would need 4 machine C's to actually complete the task. Okay, and that's my answer for this question. All right, guys. So instead of going with 1 by 5, 1 by 10, 1 by 20, which is definitely gonna take you at least 2 times the effort of or more as well, you can solve this question using work as 20. And some of you might think that this work, assuming the work method might only work in specific work rate time questions. Trust me, guys, this can work in every work rate time question that exists on GMAT. You can apply this everywhere and easily save time. Like the harder the questions get, this method saves you even more time in that case. And these methods, I always teach my students at GMAT Quiz who work with me in private tutoring. I always teach these methods with a single intent that even if you're very good at work rate time, you might be still spending 2.5, 3 minutes to solve a question, which you can possibly solve in a minute, minute and a half. Now, why is that important to solve a question in a minute, minute and a half? Because even if it is from a comfort zone, if you can solve it faster, you can always automatically save time for the more difficult questions from your uncomfortable areas, which you're going to get on the day of the test. So it is important that you actually be able to solve some of the questions faster than usual time, so that you have time for the questions which are not in your comfort zone on the exam day. Correct? So imagine if you learn these methods for like 10 different type of questions, and you're able to apply them in the test also. You might save 1 minute from each of those questions. You end up saving 10 minutes overall, which is gold, honestly, on the GMAT. Okay, so that's the idea. So the logical method I would recommend in this case, in case you want to solve it mathematically, obviously it's my job to even tell you that. So you can always write 2 times machine 1/5 plus 4 times machine 1/10, which is rate of machine B, plus x times 1/20 is equal to 1. Now you can always solve this also, but again, here the fractions are still easier to deal with. If the fractions become complicated, taking LCM and solving this takes a lot more effort than the method that I taught you. Okay. Now, obviously, I have very less time, so I'm teaching the methods at a very high level. If you want to get into the depth of any of these, feel free to reach out to us at GMAT Viz. We teach these methods in our tutoring classes, in our online course as well. You'll get to learn it from there. Okay, so let's get to the fourth question. Now, with every question, the difficulty level goes up all the way to the last question. So we'll see those as well as we move forward. Now, when you see such questions like these, I always recommend that keep all the variables on one side of the equation, like at least a variables on the one side of same side of the equation. So I'll just write it slightly differently. I would just bring all the 4 to the power a's on one side and 176 on the other side. Just helps me kind of visualize things better. Now, there are 2 ways to do this as well. You can solve it mathematically, you can plug numbers in. Now, the reason I have not went directly into plugging numbers is like 4 to the power 3 and 4 and 5 could be like a bigger number to calculate. I did not want to do that right off the bat. So I thought, let me do it algebraically. But yes, if you want to plug in numbers, you can plug in numbers. I don't see a significant difference in any of the 2 methods in this particular question per se. Okay. Now, if I look at this, I can write the first one as, again, obviously I can explain it more in depth, but I'll have to go at a certain pace. So assuming that you know all the concepts. So I can write it like this, and then I can take 4 to the power a common. So I'll get 4 squared minus 4 to the power 1 minus, not 1, 4, 1 is equal to 176. Now, if I write the term in the bracket, it will be 16 minus 4 minus 1, which is 176. If I do further calculation, this becomes 11 and this becomes 176. Now, in that case, I can get 4 to the power a as 176 by 11, which will give me 16, which is again 4 squared. So from this, I get a is equal to 2 as my answer. All right. So you can do this algebraic manipulation and just solve this question. So any of these questions on exponents that you see on the GMAT, I generally recommend that you bring common exponents to one side and try to get the base common. Like for example, I saw 4 to the power a as a common entity in all of them. So I just took that out as a common entity, and then everything else falls into place. Like it just falls into place. So try to see which is the common base. Powers might be different. At least take the common powers out and keep the other things in. If nothing strikes, you can always use options also if you want to. Calculations might become tedious in some cases. Some cases it might be easy. There were 3 values with 4 to the power a, so I did not plug in values directly over here. Doesn't make sense to do that. Okay. Now let's go to question number 5. Now this is our first question on permutation combination. There are 2 questions I think in the set on PNC, and I'll call permutation combination as PNC in short, basically. Now this is a slightly easier of the 2 questions. Now what does it say? And PNC questions, it is very important for you to really understand and strategize before you jump into solving. And if you saw in some of the other questions also, I taught you this importance of strategizing, right? If you remember the first question, when it was on divisibility, finding the remainder, I saw it is written what is the remainder. So even though I can solve it mathematically, in the test I will not solve it mathematically, because it's a very certain keyword and it is better to plug in numbers. So this strategizing is something which is very, very critical. And as part of like a tutoring or GMAT with services, we try to teach the skills to our students so that they can actually understand how and when to strategize overall. So strategizing is a very key step. Don't hesitate in doing that. You might need to stop for like 5-10 seconds, give that additional time on a question to strategize. But if you do that, you'll automatically end up saving time. Okay. Now, if you want, any one of you wants to understand how GMAT Quiz can help you with your prep, feel free to reach out. I've given the link to connect with our team in the chat. Feel free to reach out to understand how we can help you prepare for your GMAT and get to the target score. But anyway, coming back to this, so in a PNC question, it is very critical for you to strategize. Let me just go a little more full screen into this question. So in how many different ways can 3 fiction books and 3 non-fiction books be arranged in a row of 6 books on a shelf? Okay, so I have 3 fiction and 3 non-fiction books. I have to arrange them such that fiction books are not separated. Okay, so if there are like 3 of these books, they are going to be remaining together next to each other, and non-fiction are also not separated. So let's say it is NF1, NF2, and NF3. These guys are also not going to be separated. But I can have an arrangement of these two. Like I can have the non-fiction coming first and the fiction coming later from the left, or I can have fiction on the left and non-fiction on the right. So if I look at the arrangement of the groups, I have 2 ways to arrange the groups, or 2 factorial ways, whatever we want to call it. And within each group, like within the fiction group, I can arrange these 3 books in 3 factorial ways. And within the non-fiction group also, I can arrange in 3 factorial ways. So if you look at the answer, this should be 72, which is option C, basically. So a straightforward arrangement focused question if you just understand the question stem well, right? I don't have to like arrange all 6. I have to keep them in groups, and keeping the parentheses around them just helps you visualize it better. And then obviously take into account the fact that these 2 groups can also be swapped. They need to be also arranged. Which group comes on the left is also important. So don't fall for the trap choice, which is choice B. And those of you who don't read this properly might also think of 6 factorial, which is obviously not in the answer. So you might get confused because of that. But if you understand and read this right, your concepts of PNC is clear. You'll not face any challenge with this particular question. Okay, now let's move to question number 6. Now this is where we get into the medium hard zone. Now there are multiple ways of solving this question, right? One of the ways is a traditional method, which says that okay, you use 3x plus 2 is divisible by 5. So I write this is equal to 5k, and then I get 3x is equal to 5k minus 2. Okay, then you get x as 5k minus 2 by, sorry, my bad. Let me just give me a second. I need you to write 2. I wrote 3 by mistake. So let me correct this. So I get x is equal to 5k minus 2 by 3. Now, it's a must be true question. Again, I'm not saying this is the best way to do it. I'm just telling you the mathematical way first. Okay. So this is a must be true question. So it says x is divisible by 3. Okay, now if you look at this, can I say x is divisible by 3? Again, may or may not be true. Like I don't have anything to say that this number when divided by 3 leaves a remainder of 0. I don't have anything to say that. So I cannot really say this is true. 3x is divisible by 10. Now again, if I write this 3x, my 3x would be 5k minus 2 itself, right? Now 5k minus 2, there is no chance this is divisible by 10, because 5k minus 2 is not even divisible by 5. It leaves a remainder of minus 2 when divided by 5. So there's no chance this is divisible by 10. So this is definitely false. First one, I can't be sure of. First one, there's no information to evaluate that, understand that. But second one is definitely false. Now let's look at x minus 1. So what is x minus 1? X minus 1 is 5k minus 2 by 3 minus 1, which is nothing but 5k minus 5 by 3. Okay, now is this divisible by 5? Yes, it is, right? Because I can take 5 common and I'll get something like this. Now you might say that, okay, what if like k minus 1 is not divisible by 3? Now it has to be divisible by 3. You don't have to worry about that, because x is a positive integer. Like I won't get a positive integer from this if k minus 1 is not divisible by 3. So that you don't have to worry about. Okay. So Kanishta, I'm coming to your doubt. Don't worry, I'll come back to your doubt. But I can be sure that x minus 1 is definitely 5 into another integer. So definitely this is must be true. And the moment you get one thing as true, you don't need to check any further because you know that it's a multiple choice question and there's only one correct answer in this. So you don't have to check for x is odd, x is 3, x is even, any of that at all. You can just eliminate them right off the bat. So x minus 1 is divisible by 5. I hope all of you are clear with this point. Till this point, I'll take up Karmishta's doubt. Karmishta is saying, but if the question says x is an integer, shouldn't we be able to assume that the divisor of 3 will leave no remainder? So Karmishta, understand, when you're looking at this and you're thinking that you're dividing x by 3 and then you're getting an integer. Please understand, this is not x by 3. The value that you see, 5k minus 2 by 3 is x. Okay, it's not x by 3. If you divide x by 3, what will you get? You'll not get this. You'll get this thing. Please understand that. Question is saying x is an integer. It is not saying 3x is x by 3 is an integer. You're getting my point? I don't have any clue. I cannot take 3 common from the value of x here. Let me just write the value of x in blue. Okay, this is the value of x. I can't take 3 common from this. Okay. Why option E is wrong? Okay, let me get to that. 3x is even. Okay, now if you look at 3x, okay, it is 5k minus 2. How do I know it is even? I don't have anything to say about that is even because 5k, if 5k is even, k is even, in that case 3x is even. If k is odd, 3x could be odd also. So I don't have any solid proof for that. X is odd. Okay, I don't know. Like Shivang, the same logic applies. How do I know 5k minus 2 by 3 is odd? There's nothing that tells me that. Okay. Now, as I said, this is the mathematical way of doing it. I honestly did not. I honestly don't always follow the mathematical way because, as I said, it is important for us to understand GMAT is a time test, so we need to be smart about how you solve questions. Okay. Now, what I always tell my students is that if you are doing a must be true question, never try to prove it true. Try to rather turn it into a could be false question. So if you can prove it false, even in one scenario, that's all good. You don't have to worry about anything else, basically. Even if you can prove it false in one scenario, that's good enough. So you can always go ahead and eliminate the options also if you want to, basically. All right. Now, if you look at this question, this tells me that 3x plus 2 is divisible by 5. Okay. Now it says 5 is x is divisible by 5. So what I will try to do is I'll try to find a value for x, okay, which is not divisible by 3. So I want to prove this false, right? So I'll try to find a value of x which is not divisible by 3, but for which 3x plus 2 is divisible by 5. So if I take x equal to 1, 3x plus 2 becomes 5, which is divisible by 5. But x is not divisible by 3. So I know this can be false. Now, if it could be false, if it can be false, it is definitely not must be true. Correct? So I've taken value of x as 1, for which I have proved that a must not always be true. Now, the good thing is with the same value of x, I can say 3x is also not divisible by 10. Correct? Because 3x will be 3. It is not divisible by 10, so I can eliminate that also. I can also eliminate 3x is even because 3 into 1 is not even. Okay. So we can always eliminate 3 of the choices just with one value. Now, some of you might think, Piyush, with this logic, x is odd, 1 is odd, right? But again, remember, x is just one of the values, right? 1 is just one of those values. I don't need to stick to that value. So when I look at D, I will try to prove this wrong by taking something which is even. So if I take, let's say, for example, I take a value of x which is even in this case. So if I take x equal to, let's say, what should I take? If I take 2, it doesn't work. If I take 4, it doesn't work. I can try and take it as 6. It will work. If I take 6, 3 into 6 is 18, right? If I take x equal to 6, 3 into 2 is 18. 3 into 6 is 18, plus 2 is 20. So it is divisible by 5, obviously. But x in this case is even, it is not odd. So this is also eliminated. And then by elimination, I know that C is the correct answer, basically. And if you try to prove it false, you'll always fail. Like there's no value which will work in that case. This is the second way of solving this question. Okay, guys. Now, there is one more way. Not sure if it will strike all of you, but one more way is if you want to just check after elimination that C is right or not, you can just represent this thing in this way. Just subtract 3. Okay. Sorry, plus 5. Minus 3 and plus 3 is what I'm doing. So I get 3 into x minus 1 plus 5 is equal to 5k. Okay. So I get 3 into x minus 1 is equal to 5k minus 5, which is 5 times k minus 1. Okay. And then I can write x minus 1 as 5 times k minus 1 by 3. So it is in a way the same thing that we got from the first question itself, right? First statement. So I know this is definitely divisible by 5. Okay. I hope this is clear. Now, third one is the most difficult one to strike. For some people, if you practice enough, that might come to you. Can you show by taking x equal to 1 and solve for option C? So if you take x equal to 1 km and solve for option C, let's do it, right? 1 minus 1 is 0. And 0 is divisible by 5. 0 is always divisible by 5, right? Doesn't give a remainder, like it gives a remainder of 0. Anything which gives a remainder of 0 is divisible. So no matter which value of x you take, C will always work. Okay, so I showed you 3 methods. Those who like mathematical methods, do the mathematical method. Those who don't like it, try to use the second method, which was proving it true, false. Okay, in one case. And if you're not able to prove something false in one case, you eliminate everything else, you're good. You have the answer with you, you can move forward. All right. Hope that is good, guys. So ready for question number 7? So let's do it. So just give me 1 second, guys. Okay, so let's do this question. All right. So I have a family C, D, E, F, and I always have this habit of just writing the first letters. I know many of you also do the same thing. So it really helps in many cases to just do this basically. So I have 4 people, C, D, E, F, are playing a game that requires 2 teams of 2 members each. In how many ways can they form the 2 teams? Now, this is a trap question. This is a trap question which tests you on a very important trap. I'll come to that. Now, obviously, there are 4 people. I have to pick 2 people for the first team. So I can do the selection in 4C2 ways. And then I need to do the selection for the remaining 2 people in 2C2 ways, basically. So I am then this way forming 2 teams. But the problem is happening here. The problem that is happening here is that I am selecting from the same group of people 2 times, technically. Whenever that thing happens, you need to divide by the number of selections that you're doing, like divide by 2 factorial, basically. I'll help you understand why we do that. Okay, let's understand this. Okay, so let's say if I have in the first selection I selected CD. In the second selection I could end up selecting EF. So this is considered once. But at the same time, in the first selection, if I end up selecting EF, and in the second selection I end up selecting CD, that is also considered as a separate scenario, as a separate case. So in reality, every team, every combination that you see over here is getting considered twice. It doesn't matter which 2 people you select early. For example, if you selected CE in the first go in one team and DF in the other team, it's always possible that in the next time when you're selecting, you end up selecting DF in the first go and CE in the second go. So what is happening in this case is that the order of selection is also getting taken into account. And that's why it is important that you divide by 2 factorial, because the order of selection doesn't matter. We just need to place them in 2 different teams. That's it. So Natasha, it's always 2 factorial because it's the number of selections, and 2 factorial and 2 is the same thing. Okay, conceptually is 2 factorial because if you have, let's say, for example, instead of this question, Natasha, you had 2 more people, A and B, and they asked you to form 3 teams of 2 members each. In that case, you will do 6C2 into 4c2 into 2c2, and then you have to divide by 3 factorial. You cannot divide by 3 over there, because in that case your order of selection is getting considered for 3 groups basically. So there will be 3 factorial arrangements that will happen between them. It will not just be 3 arrangements. Okay, DC and FE are different teams, definitely. DC is one team, FE is one team, but CD and DC are the same team. Okay, thank you, Natasha. I'm happy that you got it right. Now, just as a simple example, guys, if you ever forget this, I'll just give you a very simple example. In fact, let me just see if I have another screen for this. Just give me 1 second, guys. I'm gonna just create a blank screen. I don't want to remove this. Okay, so I hope now this should work. Yep. So let's take a simpler example to understand why this is important. So let's say, for example, if I have to select, there are like 5 friends, okay? 5, let's come to friends, we can call it men. Let's say there are 5 men, and we have to select a team of 2 men. Now, all of us know we do it in 5c2 ways, right? Which is 10. So 10 ways of selecting a team of 2 men out of 5 men. Correct? All of us agree on that? Now imagine that instead of doing the selection in this way, had we selected the first person first, 5c1 ways, and then from the remaining person, if I select the next person, so I do 5c1 into 4c1, I can also do that, right? I can select the first person first and the second person from the remaining 4 people. If you do that, it's logically sound, it seems logically sound, but if you multiply this, you will get 20 ways. So it's very clear, right? 10 is not equal to 20. So there's definitely something wrong with this. And this is exactly what I was talking about. Since you select from the same group of men twice, the order of selection is taken into account also. The order of selection is also taken into account. So I will teach you, just tell you one simple rule. So one simple ground rule that you need to keep in mind always. Always remember, always avoid selecting from the same group multiple times. So if you have to select from a group, don't do it in multiple goes, just do it in one go always. Always avoid doing that. So if you have to select from a group, let's say if there are 5 men and 4 women and you have to make a team of 3, okay, and there's a restriction that you need to have at least 1 man, just write down the cases that I can have 1 man, 2 women, 2 men, 1 woman, and all 3 men. Do individual cases wise answers. Don't select from the same group multiple times. Don't make that mistake. Now, in some cases, you will not be able to avoid it. So that's what I was coming to. So good point to Kamikshta. So in some cases, and that's why I've written, always avoid. I have not said don't select from same group twice. Okay, always avoid. In some questions, you cannot avoid that, because in this case, for example, you have to select from the same group twice. Even if you select the first 2 people, you would need to come back to these people and select the other 2 again, right? Because you're breaking this group into 2 parts, basically. And all the people end up, like most of the people end up getting selected. So if you're in this kind of scenarios where you cannot avoid selecting in one go, just divide by the order of selection. Just dearrange the arrangement that you have taken into account. So if you have selected twice, you need to divide by 2 factorial. If you have selected thrice, you need to divide by 3 factorial. If you have selected 4 times, you have to divide by 4 factorial. Jonathan, I can get to the answer also, but yes, I'll try to. But my idea is answer is one part of it. Explanation is also pretty important. But let me tell you the answer. So answer is B in this case. So if you calculate this, 4c2 into 6c2, 2c2, 4c2 is 6, 2c2 is 1 divided by 2. It will get you the answer as 3. So this is a trap question. And a lot of people mark C as the correct answer here because they don't understand this concept of double counting in selection. That's a very important concept. We have explained this in our course as well. We also have a detailed video on our YouTube channel for this. Let me just search for it, those of you who want to understand this concept, because this is a very common error that people fall in, like common trap that people fall in case of permutation combination questions. So I'll just give you this link as well. I think this will really help you. This is the nice, there are a decent number of questions that we have done. Just give me 1 second, guys. So again, in this session, I can't sit and explain every topic, every concept. I've just tried to help understand a few things here as much as possible. So yes, Richard, the answer is not 6, it is 2. 3, sorry, not 2, 3. So you have to divide 6 by 2. Why can't we just do 4 factor 4c2 as it is combination of 2 out of 4? So Kamishta, please understand, you are actually selecting two teams. So it is not just you're stopping at 4c2, the other two people are also getting selected. Had they not been selected, you don't have to worry about the arrangement. But since there are two teams being formed here, you have to divide by 2 factorial. Because it's not just you are doing 4c2, you're also selecting the other two. It's just because that is just two people remaining, it is coming out to be 2c2 and it is 1, you're thinking it doesn't matter. But technically, you are selecting both the groups. Understood? Great. Thank you. Perfect. Okay. So if all is good, we can move ahead to the next one. And great, guys. This was a complex concept. A lot of people take a lot of time to understand this. So those of you who got this, perfect, basically. All right. Let's go to the next one. Now, this is some people, this could be a calculation intensive question. Like, again, I know you have read this. I know you have solved this. I'm not giving you the time to read it again. So let's see what is happening. Roma was watering her garden with the help of a watering can. On the first plant, she poured 15% of the water from the can. Okay, so I generally don't take variables in these questions. I just work with numbers. So I'll just say that the can has a capacity of, let's say, 100 liters. So if she poured 15% of on the first plant, then I'll just write it. First plant got 15. So that means 85 was remaining. While watering the second plant, she poured 25% of the water that was left in the can. Okay, so on the second plant, she would have poured 25%, which is 1/4 of 85. Now, there are two ways I can go about doing this question. One part of me tells me, and this is what I usually do. The moment I see that 1/4 is not, like 4 is 85 is not divisible by 4, I would right away change my number to this, basically. Okay, I can do that. Like, I'm just saying that you should be very open-minded towards how the different things play out. So again, I'll come to this manipulation also a little later that I can do, but let's put it in with respect to 100 liters only for now. I don't want to confuse you guys with two methods right now. So the first plant 15 was poured. Second plant, and let me write the remaining portion below. It was 85. Second plant, 1/4 of 85 was poured. And after pouring 1/4 of 85, I was left with 3/4 of 85. Okay. And on the third plant, she remained 30%, poured 30% of the remaining water. So she poured 3/4 of 85 was the remaining. She poured 3/10 of that, right? One, not 1/3, 3/10 of that. So that means she was left with this much, 7/10. I hope all of you know this. And yes, some of you were asking for the answer. The answer in this case is D. That's what I remember vaguely, but we'll get to that. So 3/4 of 85 into 7/10 is the remaining value at the end. Okay. Now let's see the question is asking us. The water left inside the can is what percentage of the water? So this portion is what percentage of the water that was left just before watering the second plant. Okay. So 3/4 into 85 into 7/10 is what percentage of what was left before watering the second plant. What was left before watering the second plant? It was 85. So I just have to calculate this percentage value. So 85 gets cancelled. Do I have anything else that I can cancel? I don't see. So okay, yes, we have something. Yes, I do have something that I can cancel. So it is 100%. So I take a 0 out, and I can possibly cancel another 5, another 2, sorry. So I get this, which is 21 into 5 by 2. So 105 by 2%, which is 52.5% is my answer. Okay. Now, if you notice, this question can be solved in multiple ways. You can find exact values or keep variables or whatever. But the idea is if you don't go into calculating and keep the fractions as it is, you might be able to solve this question much faster. And which is what happened with me here. Okay. I was able to do this question faster because I did not get into solving and finding the exact values at each interval. I kept it in the fractional form. And if this kind of questions come, GMAT is really testing you on keeping it in fractional form and doing the calculations at the end. Okay. Had the numbers been easier to deal with, had 85 been divisible by 4, I would have possibly calculated it then in that case. But since this was coming out to be a fraction, I did not do the calculation. So this is another thing that you have to keep in mind. So in some cases, doing the calculation just doesn't make sense. Basically, keep it for longer as it is, it is better for you. Basically, that's the idea. Now, let's look at question number 9. Now, this is the second most difficult question in the entire set. This is another GMAT-based question. A few of these questions that we are doing today were GMAT-based questions. Some of them were from other sources, and all these questions were picked by GMAT Club, by the way. But let's do this one, okay? So this is an inequalities question. Now, in inequalities, I always recommend my students that the first and foremost thing that matters a lot is drawing the right kind of inferences. Now, some of you can solve this question by plugging in values and think that, okay, plugging in values is possibly the best thing to do. But honestly, in inequalities, you should not always depend on plugging in values, because that could take you a lot longer. You might miss one case or the other. So it's important to draw certain inferences first and then plug in values if needed later. Okay, so don't jump into just directly plugging in values. Now, those of you who want the answer to this question first, I can tell you that, but it will kill the fun that I want to get to. So I'll hold on to that for now. We'll come to the answer. It was already shown on GMAT Club, by GMAT Club earlier, so some of you already know it, but I'll come to that later. So let's first draw inferences as we need. So if P is less than 0, this is given to us, right? So P is negative, okay? And the value of 1 minus P by Q is between 0 and 1. Now this is important. 1 minus P by Q is between 0 and 1. What does this tell you guys? What does this tell you? Can you guys tell me what can you infer from this? Let me hear from you guys. What can you infer from this? Let's push ourselves a little. And understand, there are two ways to infer here, okay? One way is mathematical inference, the other way is logical inference. Perfect. Shivang says P by Q is a positive fraction. I think you mean positive proper fraction, right? Less than 1. KM says P and Q are both negative. Perfect. So I can flip this around and I can simply say that P by Q is between 0 and 1, because if 1 minus P by Q is supposed to be between 0 and 1, P by Q is also supposed to be between 0 and 1. You can deduce this logically, or you can also deduce this by taking this part of the inequality first and subtracting subtracting 1 on both sides, and this part other inequality, and doing that a different thing there. So you can always do it mathematically also. I'm not showing how to do it mathematically, but you can do this inference logically or mathematically, whatever you want to. So if you see this, then you know that P by Q is positive. And since P by Q is positive and I know P is negative, I can also infer that Q is also negative. Okay, but I would not stop at that. Another thing which I can for sure infer over here is that P is greater than Q. Now, how do I know that? Focus on this. I know this. If I multiply Q on both sides, okay, what will I get? I'll get this. Now the sign will flip because I'm multiplying something which is less than 0. Correct? That's a rule of inequality. So I know P is greater than Q. Now, how many of you drew this inference when you were solving this question before looking at the statements? How many of you drew this inference? Tell me, guys. How many of you drew this inference? Show of hands. I can't see your hands, so yes, you have to say yes or no. Prasanna, I'm coming to the answer. You're too worried about the answer. It will give the fun right now if I get to it. Okay, Natasha says no. Karmishta says I did. Morgan says yes. Great. So happy. A few of you did that inferencing. You are on the right track, and that's what you need to do always, every single time in an inequalities question. Draw these inferences. Okay, and I know that there are so many of you who are not saying no, but you had not come to this inference. I know that because I teach so many students every single day. I know people don't do this inherently. It is important to do this. It's very helpful. Now, had you done this, guys, understand, you will see statement 3 is correct right away. It's just saying the same thing. P is greater than Q. Now, I would then look at the options and I know that these two are definitely out. So I have to check 1 and 2 also. And I know for sure that only one of 1 and 2 is correct, or both are incorrect. Now, out of the two, I see this is easier, right? Easier to deal with, right? I am seeing P, which is a negative entity, and 1 by Q, Q is negative, so 1 by Q is also negative. So I'm adding a negative entity to another negative entity. So sum is definitely going to be negative. So I know 2 is also true, and hence my answer is E. I don't even need to check for statement 1. Okay, I don't even need to check for it. And that's something which you can do in a lot of inequality questions. Okay, eliminate a few things, or at least prove a few things, and then you can go ahead from there. You don't have to sit and like really solve every bit of it, basically. Now, those of you who want to know why p square plus q square may not be greater than equal to 1, you need to understand that p and q could be fractional values, right? You can have p as minus 0.1 and q as minus 0.3. Even if you square it and add them, you'll not get greater than 1, basically. Shivang, I just did that, basically. So if you are thinking it is possible to have it greater than 1, you are assuming P and Q are integers. And that's another thing which I recommend people to be very aware of in inequalities, which is to be aware of the constraints. They have to be extremely careful about the constraints, not just the ones which are written there, the ones which are not written there. The ones which are written there, they have to be assume anything like that as well. Now, there are like 3-4 more things that you have to do in inequalities, usually that I teach as part of like our sessions with students. So definitely there are other things also we need to keep in account, but these two top the list. Very critical guys. Okay, so that's the best way to solve this question. Now let's get to the last one, which is question number 10. Okay, now this is the most difficult question in the entire test set that you guys did. So let's get to this. Now it says x is a positive integer. I know x has 8 factors. Now the moment I see that, I would try to write x in form of p1 to the power a, p2 to the power b into p3 to the power c. Now, since it has 8 factors, I know that it is a plus 1 into b plus 1 into c plus 1, which is equal to 8. Now, it's possible that it might not have 3 factors. It is possible that it has only 1 factor. In that case, 1 prime factor, I mean, not 1 factor. So that case, a is equal to 7. So x could be of the form p1 to the power 7. The second scenario, this is case 1. Second scenario is that x has 2 prime factors. In that case, I can only write 8 as 4 into 2. So in that case, a will be equal to 3 and b will be equal to 1. So x can also be p1 cubed p2 to the power 1. Third scenario is it has 3 prime factors. 8. So a equal to b equal to c equal to 1. So I have 3 cases possible for x, and this is the inference that I have drawn. Okay, I think Urban, this video will be available to watch later. I guess should be there because it all stays on GMAT Club channel, YouTube channel. Okay, so it's P1 into P2 into P3. I hope all of you are clear till this stage, right? Till this point. Okay, let me just get another slide for this. I don't want to rub this. If you, any case one has a doubt, I can always refer back to it. So just create another slide. If all of you are clear to this, till this level, what is important is this 3 inferences, this 3 cases that we have drawn over here. Okay, so these are the 3 possibilities for x. Now let's step into x plus 1. Now x plus 1 has 4 factors. Let's think of that. So x plus 1 has 4 factors. Now using the same logic, I can write that it can have p1 like it can just be p1 raised to the power 3. Again, 4 can be written as 3 plus 1. I'm jumping a step here. Or I can write 4 as 2 into 2. In that case, it will be 1 plus 1 into 1 plus 1. So in that case, x plus 1 is p1 into p2. So what I know is x plus 1 can be one of these two. And again, this could be different p's, by the way. Okay, let me just write it as p4 and 5. And the x possibilities for x is P1 to the power 7, P1 to the power 3 into P2, or P1, P2, P3. Okay. Now, obviously, x is less than 100, so I have to like consider prime factors. So Shivang, 3 prime factors because 8 can be written as 2 into 2 into 2. If it is 2 into 2 into 2, just do one thing. If x is P1, P2, P3, how many factors does x have? You tell me what is the number of factors, and you will understand why it can be 3 prime factors also. Okay, you'll get to know that right away. Okay, so I have to check cases when x is less than 100. So if I take case 1, only one value of x will satisfy this, which is 2 to the power 7. Let me see if it satisfies also. I don't think that will also satisfy. 2 to the power 5 is 32. 2 to the power 7 is 128. So that also doesn't satisfy. So x cannot be equal to p to the power 7. That will definitely, that cannot happen. So let's see the last one is also easy. Let me do the last one and then come to the second one. So the last one is 2 into 3 into 5. If I take these three numbers, x can be equal to 30. If I take any other prime factor, let's say 3 into 5 into 7, I will hit 105, which is greater than 100. So this will not be possible. So if I take x equal to 30, I need to have 31 x plus 1 in the form of either a prime number to the power 3 or product of two prime numbers. Now 31 is clearly a prime number in itself. So it cannot be written in any of the two forms. So x equal to 30 doesn't work either. Okay. I hope this is clear to all of you also. So x cannot be the first or the third case. Okay. So from here, I can definitely infer that x is only case number 2, which is what we will solve for now. So x, wait a second. Let me just get this. So x, I know for sure, is p1 to the power 3 into p2. Okay. And I know x to the power x plus 1 has to be of the form p4 cubed or p4 p4 into p5. Okay, has to be of these two forms. Okay, now I just need to check. Now x less than 100 is there. Okay, so if I take p1 as 2 first, I need to put in another prime number next to it and still keep the product less than 100. Right now, 2 cubed is 8. So if I look at what can I multiply with 8 and still keep it less than 100, then I can go all the way up to 12, right? So what are the prime numbers up to 12? So I have 3, I have 5, I have 7, and I have 11. Okay, so this is a structured way of solving this question. You got this, guys? I first fixated P1 as 2. So I got 2 cubed. Then I'm thinking x is less than 100. So what do I multiply with 8? What can I multiply with 8 to keep it less than 100? Anything which is smaller than 12. So instead of randomly multiplying and randomly taking cases, take the cases in a structured way so that you don't miss the values, because there are like very close answers here. So in the first case, x will be equal to 24. Second case, x will be equal to 40. Third case, x will be equal to 56. And the fourth case, x will be equal to 88. Okay. Now, I don't recommend checking for x1, x plus 1 right away and eliminate the answers. I would say write down all the possibilities of x first, and then we will eliminate which one of them are fitting for x plus 1 also. Okay. So I've tried with p1 as 3, p1 as 2. Now I will try with p1 as 3. So if I do 3 cubed instead of 2 cubed, I am already coming to 27. Now what can I multiply with 27? And what prime number can I multiply with 27 and still keep it below 100? So the only prime number that I can possibly multiply is 2, because the moment I multiply 5 with 27, it is greater than 100, right? So this number is 54. Now, if I try with 5 cube instead of 3 cube, that itself is 125. So this doesn't work. So there are 5 possible values of x: 24, 40, 56, 88, and 54, which fit this format. But I also have to make it fit the other thing, which is x plus 1 should be of the form a prime number cubed or a product of two prime numbers. So let's see x plus 1 for each of these numbers. So if you see x plus 1, in case of x being 24, it will be 25. In this case, it is 41, 57, 89, and 55. Now, 25 cannot be written in the form of product of two prime numbers, right? It's actually 5 squared itself. And it is not the cube of a prime number either. So 24 also, it doesn't work. 41 itself is a prime number. Doesn't work either. 57 can be written as 19 3s are. 19 3s are. So it's 19 into 3. So it fits this form. So this works. 89. Now, is 89 a prime number? Let me do a quick check. So I just need to check till the square root of 89, which is 9. Again, that's another thing which we teach in GMAT quiz. If you want to find out whether a number is a prime number or not, just check whether it is divisible by any prime number till its square root. So square root of it is around 9. So it is not divisible by 2. It is not divisible by 3. Not by 5, not by 7. Let me check with 7. 70 plus 19, not divisible by 7. So I don't need to check any further. So this is also a prime number. It cannot be written in any of the other forms. It doesn't work either. 55 can be written as 11 into 5. So this also works. So there are two values of x which work, which is 88 and 54. And hence my answer is 2. Okay. This is the most difficult question in the set. Now this question helps you understand and learn how to take cases, how to systematically take cases in an organized way. And if you notice, at every place I have done that. Like if you go to this question, this slide, I systematically took, like before this slide also, in fact, in this slide, I systematically took all the possible cases for x, like with 1 prime factor, 2 prime factors, and 3 prime factors, and came down to this inference. Then I did the same thing with x plus 1 and came to this inference. Then I did the same thing and eliminated 2 of the cases over here that first and third case is not possible systematically. And then I went ahead and with the second case, I took P1 as 2 first and went ahead by finding the other cases by not plugging in values, but doing is systematically. Okay. It is time consuming here. And that's the only way to do this question. And there are hard questions like this, which could be time consuming. This question would take you 4 to 5 minutes to solve. Okay, and there would be 1 or 2 questions in the GMAT which will take you 4 or 5 minutes to solve. I can show you scorecards of people who have scored Quant 90 consistently, multiple tests. They also take that time. Even experts sometimes take some time on some hard questions. And that's where you need to understand that you can't solve every other question in 2 minutes. There has to be a few questions which you need to do in 1 minute. Urban, you have a very important point. So understand, there are 21 questions on GMAT. If you're thinking every question should be done in 2 or 3 minutes, you're wrong. You're very wrong. Trust me. But imagine it this way. If you can do 10 questions in 1 minute, okay, you have how much time? You have saved 10 minutes of time, right? Now, out of the 11 questions which are remaining, let's say out of the 11 questions, there are 7 questions where you spend 2 minutes each. So 14 minutes are gone. Okay, you still have 4 more questions to do, but you have 10 minutes extra for these 4 questions. Please understand that. So you can easily devote 4.5 minutes also in these 4 questions, and your total time will be 18 minutes. Okay, if you add all of this, 10 plus 4, 14, 24 and 18, you still have done 42 minutes. In fact, you can actually do 5 questions with 4.5 minutes of, maybe 4 questions with 5 minutes. You have time to do that, and that's how it works. You don't have like more than 4 or 5 very hard questions in the GMAT, which is like this. In fact, I've taken the GMAT several times. I've not seen more than 2 or 3 hard questions which will be of this difficulty level. So what you need to understand is you cannot solve the harder questions in 2 or 3 minutes. May not be possible for you to do that. But what is definitely possible for you to do is you can possibly do 10 questions in 10 minutes, which will be the easier ones. And that's where the better methods of using LCM, work as LCM, which I was talking about in work rate time, or for the first question, which we talked about, basically where we can take a number because it's a very certain question. It says, what is the remainder when x is divided by 5? Those nitty-gritties you need to learn. Those important things you need to learn. I'm not using the word shortcut because those are logical, legit methods. So there are many of these methods that we teach to our students at GMAT quiz, and I would recommend you to learn these methods. So important to learn the right methods. At a high level, I'll just tell you, for CR, use pre-thinking, RC, use involved and evolved reading. In DS, drawing inferences and pre-analysis is a very important step. problem solving, we have a 3-step process that we teach for different type of questions, and your data reading is very important, and how you read data for different type of questions is also very important. So all these methods are very important, and initially it is important that you learn the right method and don't worry about time. As you move towards a fine tuning phase, that's when you should start focusing on timing. If you have learned the right methods, please understand timing will automatically fall into place, basically. Okay, so feel free to do that. So yes, Morgan, I'll be on the call that day. So in case you want to reach out to us, feel free to reach out to me on piyush at the rate of gmatris.com, or I have also given my WhatsApp number. I'll also pass on the link to block a time on my calendar in case you want to understand how our team can help you solve questions better, learn better methods. But idea is that if you really want to do well on GMAT Quant, especially, you should be able to get into a position where you can do very well on a few questions and solve them faster, so that you have more time for the harder questions, which will be some. Like you will be thrown off by a few questions here and there. You might need to spend 4 minutes on those, but you will have that time if you're able to do better on the questions in your comfort area also. Okay. So if you like the video, do give it a like and thumbs up. This was the first time we tried doing something like this with GMAT Club. So I hope you guys enjoyed the session and it was helpful in getting some concepts across. At least through 10 questions, we can get some questions. And as you can see, there's just 4 likes. So if you really like the video, do give it a like and spread it to your friends. And we'll do more of this session. So if you really like this one, okay. So thank you so much, guys. I have a meeting starting just now, so I'll have to jump onto it. But if you need me to, feel free to reach out to me. Happy to connect with you guys in case you have any doubts. Okay. Thank you so much. All the best, guys. I'm ending the stream now.